so let's take a look at this one, which is 102. Here you get to see how compressed files work. So you're going to need PuTTY, and I should have PuTTY here in the downloads folder probably, or perhaps on the desktop. There's PuTTY, all right. And there's PuTTY comp. I'm just going to move it to my desktop. So I'll copy and put it on my desktop, which may be less cluttered. Yeah, it is less cluttered, all right. And we'll work here. So I paste, all right, so the first thing I have to do is compress it. Now, on these machines that I prepared, I put the tools in C tools. I'm using a ARM machine here, but it will still work because you can run Intel software on an ARM machine. There's some kind of conversion process. So in here I have UPX, upx.exe. So I can run it here. Now however, my malware is on my desktop. The thing I want to work with, it's PuTTY, it's not malware. So let me try moving to my desktop, and let's see if I fixed the path. I think I did. C users, student, desktop. All right. And let me set this up so I'll see comments in the Twitch. All right, so in here, here's the file I want to work with, PuTTY. Now I want to use UPX, and if I just type it, it can't find it. Okay, this happens when you haven't got the path set correctly. Let me change my font, by the way, to make this a little easier to see, if it's going to let me do it. Should be properties somewhere.
You should have more properties.
Well, this is PowerShell. Maybe Microsoft hid the properties somewhere. Settings. Holy cow. Appearance. Is the font in here somewhere? Wow, that's Microsoft for you. Made it confusing. Use acrylic, always on top. Oh, for crying out loud. Well, there's probably some way to change the font in PowerShell, but I'm just going to use a normal old command prompt that I know how to use. Microsoft has hidden the settings because Microsoft exists to drive us all mad. Anyway, here it's down the terminal, opens PowerShell. Okay, how about Control Plus? That would be nice. No, Control Plus. Control Plus works. Oh, good. Okay, good. They took it out of the menu, but they put it back in somewhere good. Okay, so now if I do to the desktop, okay, now if I do a directory, good. Oh, this is the modern terminal. Microsoft's new modern terminal replaced the old command prompt. All right, so there's the tool I want. So I'm just going to give it the full path to my UPX. This is one way to do it, tools UPX. All right, now I can run it from anywhere. If I set the path, I wouldn't have to put C tools in it, but this is not too bad. So I want to compress it, and you'll find the instructions here. Whoa, some Alt-Tab. It's not moving over with Alt-Tab like it should. Perhaps they've changed that key press 2 or something to drive us nuts. I want to do UPX-O and PuTTY. The default is compress. Now Alt-Tab should move back, and it does. All right, so now I run C tools UPX, and the output is PuTTY comp.exe, and the input is PuTTY.exe. That should do it. Now if I do, and see it tells you it shrunk from 500K down to 267K. So if I do a directory, both programs are here. And if I run these will both run exactly the same. The PuTTY comp is compressed on the disk, but when you run it, it decompresses into RAM and runs the same. So that's the point of a executable compressor. All right. So we can now examine it with, say, PE Studio. Let's see if I have PE Studio on this machine. I may need to install it. I do have it. Good. All right. So here's PE Studio. It's a very nice, powerful program. It shows you a lot about portable executables. So I'll open PuTTY from my desktop. All right. And then I'm going to make another instance of PE Studio. Right-click, Open, that should make another one. Yep,
Went
I think it's opening another one. Maybe not.
up. Oh, no.
Right click, maybe right click and left click on it.
Perhaps you can add a tab, because now.
Oh, here we go, it's there. Yeah, it's finally coming. Yeah. All right.
Oh,
Just a little slow. And that's because I'm running Intel software on ARM, so it's being translated, so it's slowing things down. All right, so now I have the two different programs. And so if you look at a normal PuTTY, you can see a lot of things here, and if, like VirusTotal gives it a score of 0, it's not malware. If I look at the sections, it's still figuring out the sections. All right, but I can see the size here. And the overall entropy is 6.7. That tells you how much disorder there is. This is 500K, and entropy 6.7. This,
high entropy, right?
that's high entropy. Yeah, 8 is the max, yeah. And this one here is 267, and the entropy is 7.8. So it's smaller, and the entropy is much higher, because this is compressed data. And compressed data has the highest possible entropy. You've removed all the unnecessary bits. That's the idea. So all the bits contain information now. So, and if you look at the sections, here you see the sections in the compressed file are very strange. It's UPX0, UPX1, and resource. And UPX0 has no entropy because it's size 0. This one has entropy of 7.9 because it's compressed data.
Virtual size versus disk size.
Yeah, and you'll steal sizes I haven't filled in yet, but they will. So what's happened is the compressor has put all the file in this one area and compressed it. And the unpacker will unpack it and put it in RAM as if it came from a normal executable. But a normal executable looks like this. The sections should be, you have text, RData, data, and resource. And when the sizes fill in, which are taking a long time to size, you'll see these all have about the same size on the disk and in memory. So, all right, that may be enough to point out about this stuff. Let's see. All right. Permissions. Yeah, let's check the permissions on the sections. Here we are. This one here, the text section should tell me, yeah, permissions should be down here, but I'm not seeing them, which is pretty rude. It may be that it's just taking time for them to appear. But anyway, the point is you'll see read, writable, executable, and shareable. And for a normal executable, the rule is write or execute. You have this area is writable for data. That's where stuff is going to go in like a file name you type. This is executable. That's the text section. But the two are never both printed at once. So you cannot have self-modifying code, and none of the data you put in can be executed. That's the idea. But PuTTY has got writable and executable for all of them, the compressed version. And it's going to flag that and turn it red and say, this looks suspicious. This is not a normal program. It's not supposed to have those permissions. All right, and now you can look at the imports. Let me go there. PE Studio may not be ready yet. It takes a little time to process the file. But yeah, here's the imports. All right, this is the compressed version. So notice there's only about 15 functions used. Load library, get process, play sound, open printer. I don't know why it's there. Just a few things. That's very strange. And if we look at the other one here, the imports, there are 312 imports. This is what a normal program has. It uses a whole bunch of libraries, a whole bunch of imports. So the other one that's compressed, all you're seeing is the decompressor. All right. So now you can find a flag on an entry point here just to show you've got this thing working. And now we're going to decompress it manually. Now we know the UPX is an open source compressor, and we can use UPX to unpack a UPX compressed file. That's nice, but often you won't have the decompressor because the malware author makes a custom one, or they use one that's on the black web that you don't have. But you can always easily unpack it yourself with OllyDebug. Because, of course, it does have an unpacker built into it. So all you have to do is run the unpacker, and this is just what we were talking about in the lecture. If there's a process that's hard, like encryption or compression or decoding, you don't figure it out, you just use the code the bad guys wrote. and then stop it before it goes further. So we'll run ollie, and we'll decompress that compressed file. So it's going to warn me I don't have administrator rights. I don't need them. I'm only doing user land debugging. So I'll go to my desktop, and I'll get putty comp. There it is. All right. And I'll make another instance of ollie and open the normal putty. Now, by the way, putty comp is going to notice a statistical test shows something seems to be wrong here. One of your sections appears to be compressed or encrypted. Yeah, that's true. It also notices this is not a normal executable. I can make another copy of putty.
So what is the compression? Similar?
Yeah, one of the sections has too much entropy, looks compressed. And so now I open normal putty, and that's here. All right, now we can compare the two. All right, so normal putty is here. It starts at 4FF EF0 and starts with push 60, push putty, call putty. Those are the first few assembly language instructions. But here's the compressed one. Wait, can I get this to stay over here? Okay. Here's the compressed one. It starts with push, move, LEA, push. It's different instructions. And that's because this is not putty. This is the decompressor. But you can spot it. It's actually pretty easy. All you have to do is scroll down in this window, and you don't have to go very far. A few screens down, there, just a bunch of zeros. And the last thing before you hit the zeros was a jump to somewhere. So everything up to this point was the decompressor loading it into memory, and the jump is running the decompressed file. That's why, even though the decompressor might be complicated, I've got it. It came with the code. All I have to do is run it. That's often what you do. You use the malicious program they wrote to undo whatever part is hard. So all I need is a breakpoint here. And I can set that with F2. And there it is. That's a returns red, that's a breakpoint.
How did you do the breakpoint?
F2 on the keyboard. There's also a way somewhere up here. Yeah, all right. So now, let's look at the memory sections here. If I view memory, all right, this is the compressed file. So there's other parts. Here's the actual putty down here a little bit. Let me scroll down a bit to bring it up. All right, so there are 3 sections here. In fact, there we go. That's probably cut it out. Right, there's UPX0, UPX1, and resource. That's all there are. And notice this, here's the memory locations of them. These are the 3 sections of the file. So if I look at UPX0, for example, I can dump it, and that will just show it to me, and it's all full of zeros. There's nothing in there. Now, if I go to the normal putty and view the memory, then you'll see there's the sections down there. It has the normal sections, text, RData, data, and resource. And if I look at the text section and dump it, that's what it should look like, all this stuff. And it was able to interpret it as instructions and so on. So that's what it should look like, 56, 6A, 0C, and so on. But instead, it's all zeros. So what I do is I run the decompressor, and the way you run it, let me go back up to the start just so we can see it. The start point is up here, just a few screens up. There it is. So I can push ahead. So now I want to run to the breakpoint. And you can do debug, execute. There, step into, step over. And those are the 2 single steps. And then there's, should be continue. It's F9. Where are they hidden F9? There it is. Run, right at the stop. Run is F9. That will run until it hits a breakpoint, which is what I want to do. F7 is a single step. Step into an F8 is step over. So actually, let's demonstrate that. If I use F7, I'll press F7 here, it executes 1 instruction, and 1 more, and 1 more. I could keep doing that. F8 will run with step over. So if it calls a subroutine, it'll go over it. But then F9 will just run until it hits a breakpoint. So I press F9, and it runs and hits the breakpoint and stops. And now, at this point, that memory section is now decompressed. So if I view memory here, and then I want to get to the third window, which was the dump, see, all this code has appeared. This was all zeros before. That's what the decompressor did. And now it's 566A0C, and that's what it should be, 566A0C. So it is decompressed and put it here. Now it's just going to run normal PuTTY. And if I want to see that, I can take one more step here. If I do an F7, it will take one step, which will jump. So I'll do that F7. I think it's this one. Okay. Breakpoint. I'm trying to hit F7. There's a little, this is it, F7. There we go. There, F7, it's jumped. And now that should look familiar. If I can get back to the main menu here, main window, there, push 60, push PuTTY, push call PuTTY. This is PuTTY. It's now starting, it's even at the right address. So the decompressor set it in memory just like the original program. So now it will run exactly identical to the original program. And that's why you can decompress things. Now the decompressed file is in memory, and I can write it to the disk. There's a PuTTY optional feature that does that called ollie dump. So we do all this we just did. We've already manually unpacked it. And now we're going to make a dumped file, and you do that with ollie dump. Plugins, ollie dump, dump debugged process. So there's PuTTY comp. Plugins. My ollie dump is not there. All right, I'll have to install it. On this machine, I don't have it installed yet, but I'll just talk about it. So you go plugins, ollie dump, dump debugged process, and then it will dump it. And the only thing you have to watch is the starting point. So the start address is here and the modify is there. These two numbers added together have to add up to the right starting point, 4550F0. And as you can see, they do in this case. So then you dump it, and it will dump an image back to the disk of the uncompressed file. Now, when I do this, sometimes it is not perfect. That file won't run well, but it is reconstructed, so now you can see the function calls and strings. If you examine the dump file in PE Studio, you'll see a lot of the imports are back. Remember, the original one had like 300-something imports. Now I have 277 imports. So the file is pretty much restored. And you can therefore see the right entry point and the right strings and stuff. And so there are some other compressed files you can manually decompress this way. This is a useful technique. And just what we were talking about in lecture, when you just use some of the malware code to do the job, and therefore you don't really have to understand it and reverse engineer it, reproduce it. So let me stop this one, this recording.